Stoichiometry is calculations involving a balanced reaction equation. Whenever we try to calculate any property using the balanced reaction equation as the basis for that calculation, that those kind of calculations are called stoichiometry. And basically, the big picture shown here in this slide is what stoichiometry is all about. And I hope you will not look at this big picture as a whole, but rather break it up into pieces and use it as a guide to calculate what is required from the data given. Now, you've seen something like this before in a previous chapter, and it is really the same thing. For example, we already know how to calculate, or excuse me, how to convert between particles of a substance and moles of a substance using the Avogadro number. We already know that, whatever A and B happens to be. We also have seen before how to convert between moles of a substance and mass of that substance using the molar mass of that substance. That's also not new. We've used it several times. And of course, mass of a substance and volume of a substance can be converted between each other using density as an equivalence factor. And we've done that as well. The only new part that we are adding in this session is the mole relationship between A and B using the coefficients in the balanced reaction equation. We said in the previous session that the coefficients in a balanced equation give us the molar ratios between the substances involved in a balanced equation. So if A and B are two substances that are part of the same chemical process, the same chemical equation, then this picture works. In other words, we can go from any part of this picture to any other part of this picture, and those calculations are called stoichiometry. So let's look at an example of such a calculation. Go ahead, pause the recording while you read the question and absorb the data. So in this question, we are told that the reaction is we're given the reaction equation itself. We know what the equation is. Of course, we need to write it down correctly using the chemical formulas and then balance it. A balanced reaction equation is the basis for all stoichiometric calculations. So unless you have that, unless you have a correct balanced reaction equation, you cannot do any of these calculations correctly. So let's do that. That's the first step. When you see an equation, write it out. So titanium 4 chloride will be TiCl4, reacts with sodium to produce sodium chloride, that is NaCl, plus titanium, Ti. And if you balance this equation, you get 1 TiCl4 plus 4 sodium plus gives us 4 sodium chloride plus 1 Ti titanium. Once again, guys, please pause the recording at the places where you need to work on these things yourself before you watch the video. These are best learned by doing these calculations and balancing on your own. Okay, since we are in this process, why don't we also calculate the molar masses of the two compounds in this equation? So titanium 4 chloride has a molar mass of 189.67 grams per mole, and sodium chloride has a molar mass of 58.44 grams per mole. Okay, so now let's evaluate this question. We are told in this question that we need to calculate the mass of sodium chloride that can be produced as a product if we used 3.846 times 10 raised to 4 milligrams of titanium 4 chloride. In other words, we are given the mass of A being titanium 4 chloride in this case, and we are asked to convert that into mass of B, where B is sodium chloride in this case. So if you once again use this picture as a guideline to the path you need to follow in order to do the conversion, mass of TiCl4 will first be converted to moles of TiCl4 using its molar mass. Moles of TiCl4 will be converted into moles of sodium chloride using the coefficients in the balanced equation, and then moles of sodium chloride can then be converted into mass of sodium chloride using the molar mass of sodium chloride. So that gives you an idea as to how to set up a problem such as this. Okay, so let's set it up. Always start with what's given, the data given that needs to be converted. So in this case, that would be 3.846 times 10 raised to 4 milligrams of TiCl4. Now, as always, I encourage you to not get lazy about writing out the units and the label of the substance completely, so you do not get confused as to which substance the amounts belong to. Okay, now the mass of TiCl4 is given in milligrams, but if you remember, molar masses are always in units of grams. So our first step would, of course, have to be to convert milligrams of TiCl4 to grams of TiCl4. Milligrams would cross out. Okay, once you have grams of TiCl4, now we can convert grams of TiCl4 to moles of TiCl4. Once again, take care of the units first, get them set up correctly, and then fill in the details. Then you can go from moles of TiCl4 to moles of sodium chloride. That's the second step in the picture. Once you have moles of sodium chloride, we can convert that into moles of NaCl, can be converted into grams of NaCl using the molar mass of NaCl. So moles, everything crosses out. At the end, we are left with grams of NaCl, that is mass. Okay, so let's put in the numbers that go along in all of these conversion factors. 1 milligram equals 10 raised to minus 3 grams. From the molar mass of TiCl4, we know 1 mole of TiCl4 has a mass of 189.67 grams. From the coefficients in the balanced equation, we know that 4 moles of NaCl will be produced from 1 mole of TiCl4, and then 1 mole of sodium chloride has a mass of 58.44 grams. Okay, so this problem is now set correctly and ready for you to calculate. When you calculate, the answer comes out to be 47.40027205 grams of NaCl. It has to be rounded to 4 significant figures based on that. In other words, the final answer therefore is 47.40 grams of NaCl. So this is an example of a stoichiometric calculation that uses a balanced reaction equation, in this case to go from mass of one of the reactants to expected mass of one of the products. Okay, let's look at this next problem. Once again, please pause the recording while you read the problem and understand the details. Now in this problem, we are told that glucose is undergoing fermentation to produce ethyl alcohol and carbon dioxide according to the equation that's given. It's not balanced yet, so our first step of course would have to be to balance it. If you balance this equation, you get 1 glucose producing 2 ethyl alcohols and 2 carbon dioxide. That way all the atoms are balanced completely. They're asking us to calculate how much glucose, which basically indicates mass of glucose, let's say B, let's call it B, it doesn't really matter what is A or what is B, from 1 gallon of ethyl alcohol. In other words, we are given the volume of ethyl alcohol. Let's call that A in this case. So in other words, your path is to go from volume of ethyl alcohol to mass of ethyl alcohol using its density. Mass of ethyl alcohol goes to moles of ethyl alcohol using its molar mass. Convert that to moles of glucose using coefficients in the balanced equation, which can then be converted into mass using the molar mass of glucose. So that is the path that we are going to use. Again, start with what's given always. So we are given 1.00 gallons of ethyl alcohol. Let's see to H6O. H6 is because of H5 plus H made it H6. It's a molecular compound. So yes, we can do that. Now the volume is in gallons, but the density is given, the volume unit in the density is cc, that is centimeter cube. So please remember, centimeter cube can be related to mLs. mLs can be related to liters, and liters can be related to gallons. So we first have to make that connection before we can do anything else. In other words, first you need to convert gallons to liters. Liters then get converted to mLs, and mLs would have to be converted to cc, which is centimeter cube. Now this is cc's of C2H6O, just to keep it straight. Now that we have volume of ethyl alcohol in cc's, we can now use density of ethyl alcohol that is given, that says 1.029 grams of ethyl alcohol for every 1 cc. cc crosses out. And now we have grams of ethyl alcohol, which can be converted into moles of ethyl alcohol. The molar mass of ethyl alcohol is calculated out to be 46.08 grams. And then once you have moles of ethyl alcohol, that can be converted into moles of C2H6O, can be converted into moles of glucose, C6H12O6. And of course, moles of glucose can then be converted into mass of glucose using molar mass of glucose. So 1 mole of glucose, C6H12O6, grams of C6H12O6. And if you calculate the molar mass of glucose, that comes out to be 180.18. So moles cross out, leaving us with mass of glucose, and that's what we are trying to calculate here. Okay, let's fill in the other information. 1 gallon equals 3.785 liters. You didn't have to memorize this, that this information will be provided. But you do need to know that 1 ml equals 10 raised to minus 3 liters, and that 1 cc equals 1 ml. This is also something you must know. When you do the calculations that is set up here, the calculator answer comes out to be 7,614.569854 grams of glucose. And this needs to be rounded to three significant figures because of 1.00 gallons that is given. Density has 4 sig figs, while the volume has 3, so 3 significant figures, meaning we need to round off right there. So the answer becomes 7,610 grams of glucose. Can you write this as a scientific notation, meaning 7.61 times 10 raised to 3 grams? Absolutely, you can do that as long as the number of significant